Assalamu alaikum everyone. My name is Hamzal Imran and I'm a grad student at Icosst Islamabad, and I'm also working as a design engineer at eMamba Private Limited. Today the paper which I'm going to present is titled as IoT based smart fan dimmer with suppressed humming sound and non-linear effect of inverters. So if you talk about Internet of Things, they are essentially the internet connected gadgets. Or you may say they are physical devices that have a capability of sensing, processing, and sharing data with each other via some communication medium. And usually that communication medium is internet. In undeveloped countries like Pakistan, we have a problem of load shedding. And to cope up with that problem, we have developed UPSs, uninterrupted power supplies. The problem with locally available UPS is that they do not produce sine wave. In fact, they produce a square wave along with higher frequency components. When locally available fan dimmers are being operated on such signals, they start producing humming noise and their life also get affected. So we try to solve this problem. We come up with a new circuit which do not get affected by this sine wave. Along with that, it does not produce a humming noise. And keeping in mind the scenario of Internet of Things and smart homes, we have given it a capability to connect to internet and then being controlled by a user's smartphone via interface or the voice command. So to solve this problem, we divided our project into two ends. The first one was developing a power electronic design, and the second one was giving it a capability of Internet of Things. So the final design of the dimmer, the circuit design of the dimmer, is presented in this schematic. It is a track based design which has FL5150/60IC and IBGTs. Later on, we changed these IBGTs with MOSFETs to reduce the cost. So, before reaching to this solution, we have developed multiple solutions and circuits. The problems, cons, and pros with those circuits is being detailedly discussed in the paper. The final solution, which whose schematic is shown in the previous slide, this is its 4-layer PCB. Initially, when we were targeting the electronic circuit solution, we were using the pot and manually controlling the speed or the PWM for the circuit. Later on, we removed the pot and added a controller with a Wi-Fi connectivity in it to be controlled by the user remotely. This slide shows you the schematic of that solution along with a single layer PCB design for that particular solution. So if you talk about Internet of Things solution or Internet of Things part of our project, we divided that problem into three sections. The first one was the selection of the modem and the controller. The second one was the selection of the protocol through which the communication would be done between the user and the dimmer. Lastly, the selection of the cloud, or later on I'm going to tell you that it was a broker to facilitate this communication between the end user and the dimmer. The overall entire solution is depicted in this system diagram. So if we talk about the selection of controller and the modem, first of all, the modem which we selected, or the medium of communication which we selected, was Wi-Fi because of its easy availability in our homes and offices. The next thing was to select the microcontroller. So our target was to select such a controller which has the internet connectivity or the modem facility inside it. So for that we did a research. We came up with 7 shortlisted candidates. Out of those, the one which was selected was ESP8266 node MCU. The selection criteria had four things. The first one was obvious, which was common for every solution. That was, it should have a Wi-Fi support in it. The second one was the price. The third one was the availability in our country, Pakistan. The fourth one was the support of software and the development frameworks. Considering these four targets, Node MCU from Espressif seems to be the best solution. The details of other options are being discussed and can be found in the paper. Moving towards the protocol. So this protocol which we use for communication was MQTT, Message Queuing Telemetry Transport. The reason of selection of this protocol were following. The first one was that it is lightweight. By lightweight, we can use it for resource constrained environments, constrained networks. So our dimmer is not going to put much of a bandwidth burden over the existing network. The second one was it's commonly being used in industry. The fourth is that it has a very simple naive solution. It has a pub sub model. So moving towards the selection of the cloud. So for cloud, in this case, the criteria was that it should give a certain amount of free tier so that we can do our prototyping without even spending some money. The second one was later on, if we want to plot the power usage and extend this project, it should give us the built-in capability of designing easy dashboards. The last one was that it should be easy to get started and learn. So out of these three, considering these three criterias, the shortlisted solutions were two, the UB-Dots one and the Adafruit one. Both were equally good in the other two capabilities, but the first one, free tier, if you talk about free tier, UB-Dots give much more facilities. So UB-Dot acted as a broker in our case, MQTT broker, giving the capability of controlling or sending the signal via voice command was also our target. The easier and off-the-shelf solution available for integrating this feature was IFTTT app. IFTTT stands for if then that app. This app allows you to send data to UB-Dots corresponding to any command which you or string or voice statement you can ask Google Assistant to do. Lastly, talking about testing of the final solution. So we did the testing on two things, the fan and a 0-watt bulb. On the right side of the slide, you can see the testing facility. So we did the testing on the main line and two locally available UPSs in the market. Okay, in this picture, you can see that we did the testing on the main line. When the main line was used as a power source, the left picture depicts that it was the okay. So basically, we used the uh, noise absorption or noise detecting smartphone off the shelf app. This app shows us the humming sound dB value being produced by the dimmer or the fan or the appliance that is being controlled by the dimmer. The first one shows the value of the noise or the humming sound being produced by a fan when it was connected to the main supply without any dimmer. The middle one shows it when it was connected to a locally available fan dimmer. The last one shows value is the one which shows when we used our own dimmer. So you can see that the least value is with our own design. This one shows when the supply was changed with UPS. So this is for the first UPS. On the left we have the humming noise sound in dBs, that was 44 when there was no dimmer attached to the fan. The middle one is for when a off the shelf solution is attached. The last one is for our own solution. This is for the second app for the same experiment, which also proves that our particular solution produced the best results. If you talk about the future work, there are certain areas of improvement or room of improvement that needs to be fulfilled in the future. The first one is reducing the form factor of the final solution, which is the smart fan dimmer, and currently we have made just a one layer PCB for that. So there, that's why its size is pretty large. Later on, its size or form factor has to be reduced and multiple layer PCBs are to be designed. And the code or the firmware which we develop for the IoT communication is being done in Arduino's framework. That is to be changed from Arduino's to ESP IDF framework. Lastly, I would like to thank Mr. Shanul Haq, the CTO of Expert Flow Solutions, for supporting us technically in the development of the fan dimmer. And lastly, I would like to thank HEC for funding our project. Thank you very much for attending our presentation.